Okay, here we go. Here's all the answers. Starting with this one, get some graph paper, oh boy. Remember, the numbers on the outside affect the y coordinates of all the points. The stuff on the inside, you do the opposite of that to the x values. So like this first one, 1/2 x, that only affects the y values, so you just take all the y values and cut them in half. So everything here that's like has a 0 for y, half of 0 is still 0. So those are all going to stay the same. 1, 2, 3, 4, 5, 6. So it's just -7, 0. I need to put it closer here. -3, 0, 3, 0, and 7, 4, 5, 6, 7, 0. But all the y values get cut in half, so like -5, 2 will become -5, 1. So 1, 2, 3, 4, 5, 1. So all the circles are just going to get shorter. And 3 will get cut to 1.5. So it's going to go, and then -2 will get cut to -1. And that's all you got right there. This one, just take all the x's and multiply them by 2. Remember, you got to do the opposite of that. Opposite of that would be to divide by half or multiply by 2. So it's going to get stretched out because all the x's, -7, 0 will become -14, 0. I'm not going to freaking do it. It's going to take all day. So basically, all these just get multiplied by 2. All of the x's. So -5, 2 will become -10, 2. And so you should end up with this longer, stretched out version of the same thing. Something like that. I don't know. Who cares? I won't have you do this many on your test. Maybe like one graphing. That one, you're just going to multiply the x's by 2 and divide the y's. Divide the y's by 2. Multiply by half. Multiply by 2. Do the opposite of that to the x's. Do that straight up to the y's. So like -7, 0. The x will get multiplied by 2, so it's going to become -14. 0 times a half is still 0, so that just becomes -14, 0. Basically, it gets long, and then the half in front makes it shorter, so it should look exactly the same as that one, but now just with shorter circles, or semicircles, or hemispheres, whatever you want to call them. Down here, divide all the x's by -2, so like -7 over -2 would be positive 3.5. You know what? I have the answers for this thing over here somewhere. What's this? Yeah. Boom, there it is. Yeah. That was easy. I just thought of that. That's the original. There's A. See, they just got shorter. There's that one that I was, A, I wasn't too far off. All stretched out, and then that's still all stretched out, and they just got shorter. And then what was the next one? Yeah, just do this stuff to the points. There's the last one. So now when you would subtract 2 and divide by -1 on the x's, and then the y's, multiply by 2 and subtract 3. Okay, next problem is the exact same thing, just now, instead of on a graph, it's just points, which is actually kind of nice, because then you don't have to draw it. I'm just going to give you the answers, because the explanation is exactly the same. Do the opposite of that to the x's, so you would add 3 and divide by 2. So add 3 to that, it's -1, divide by 2, -1/2. So A should have -1/2 for the x. Oh, look at that. Multiply by -2 and add 1 to the y's. Remember, y's straight up, x's backwards. Do that to each point, and there are all of the answers. Pause it, because I'm about to move on, if you want to check your answers. Okay, there's that side. This back side of this one, holy smokes, this one doesn't have a back. I thought this was supposed to have a back. Okay, well, I know it's supposed to have a back. It's the multiple choice one. There it is. Okay, So this one, you just got to kind of look and identify different things. I mean, I talked to like 3 different people about this problem, and you all explained it in a different way. So there's lots of ways of thinking about it. Let's see. So I would go asymptote first, meaning you know that 1 divided by 0 is where your vertical asymptote is. So what value of x will give you 0 on the bottom? If you can't do that in your head, you just go like that. Add 1 divided by 2, x equals positive a half. So it could be that one, because there's no numbers on these. It could be that one, it could be that one. It's definitely not D, though. Okay. Next thing that I would think of would be, hey, no matter what I plug in for x, I'm going to multiply by 2, subtract 1, but then I'm going to square it. So no matter what's inside of here, it gets squared and it's going to become positive. And a positive 1 divided by a positive number is still positive. And then I multiply by a half and it would still be positive, and I add. So whatever I plug in for x, I always get a positive result for y. So there's no way I can get a negative answer for y. So that can't be, and that can't be because it comes down here, so it must be that one. And there's other stuff you could do to explain it. I'm sure you might have something else, but that's enough. This, you know, parabola shifted up 1, made skinny. Should be that one, easy. That one, let's see. At vertical asymptote would be positive 1? No, because that would be negative 2 on bottom. But if I plug in negative 1 for x, that gives me 1 minus 1. So my asymptote's at negative 1. Could be that one. Could be that one. Could be that one. Oh, could be any of them. I like to do y-intercept. That's easy. That's where you plug in 0 for x, right? It tells me where it'll cross the y-axis. So if I put a 0 there, that's just 1 divided by negative 1, because negative 0 is just 0. 1 over negative 1 is negative 1. So the y-intercept is negative 1. Could be that one. Nope. Could be that one. Could be that one. Wow, I made this tough on you. Let's see, what else can we do? We've got the y-intercept, x-intercept. There isn't going to be one because y can never be 0, because 1 divided by anything can never be 0. Let's just plug in some numbers now. Like if I plug in 5, that'd be 1 over negative 5 minus 1, which is 1 over negative 6, so negative 1/6. So it needs to be down here, out here at 5. Dude, they all are. I am a genius problem maker. What else can we do here? What's different between these suckers? Oh, the horizontal asymptote. Look at this one. The horizontal asymptote's down here. That can't be. You can't, I just said you can't plug in. No matter what you plug in for x, you're never going to get 0 for y. Because you can't do 1 divided by something and get 0 as your answer. That'll never happen. So, nope. Same thing here. Nope. So I'm not that genius. I guess I'm just kind of a moron because I didn't see that right when I said it. That one was new. That's on a previous video. Graph the inside first. I think I'll definitely put one of these on there just for fun, make you do it. So if you just graph x squared minus 2, you should know that's just a parabola shifted down 2. And then if I do the absolute value of that, absolute value just means everything has to be positive. So everything down here that was negative now gets flipped up and becomes positive. Oops, that should have gone higher. Doesn't matter. I'm just getting the general shape, so it's going to go like doink, almost like the Wu-Tang Clan symbol. And so there's that. Now it gets shifted up 3, so that whole thing just moves up 3 now, so it'll be something to that effect. So no, there it is. Last one you had to do, completing the square. Or I guess you could have done a lot of things, but I would do completing the square. Pull out the negative 1, that leaves x squared minus x plus 1. Half of it is half squared is a fourth, so I have negative 1 x squared minus x plus a fourth minus a fourth plus 1. bring out the negative a fourth, but then I multiply it by -1. So 1 plus a fourth is 1 1/4. And then the inside gets factored to x minus a half squared, and then a -1. Well, they're all upside down, but I should go right 1/2, up 1 1/4. Maybe. Nope. Didn't go right a half. Didn't go right a half. Maybe. The only difference in these that I can tell just by glancing is y-intercept. This one goes through the origin. This one has a positive y-intercept. Well, if you look up here, if you plug in 0 for x, 0, 0, y-intercept should be +1, so it's got to be that one. And there's that one. All right. Now the next one. These I saw most of you doing today. Looks like I'm going to need a calculator. Right, anything in the parentheses, you plug it in for x. And these all just have r. There's not like two different ones, so this one's easy. Just plug it in. 4 minus 1 is 3 over 0, so you can't do that one. 0 would be -1 over -2, so +1/2. Plug in a half, that's 1 minus 1, that's 0. Plug in -1, that's -2, so -3 over -3, which is 1. I will probably get one of these wrong, so you get extra credit if you tell me which one. Plug in x squared, so you would just get 2x squared minus 1 over x squared minus 2. Not much you can do with that. I would just leave it. Like, you can't factor, you can't factor. You can't, absolutely cannot cancel out the x's because there's a subtraction on top and bottom. Come in here, 1 over x, so that's 2 times 1 over x minus 1 over 1 over x minus 2. That sucks. That's, got to get a common denominator and simplify that. Well, for the top, 2, that's 2 over 1 times that, that's 2 over x minus 1. And on bottom, you have 1 over x minus 2. Common denominator there would be x. So that's 2 over x minus x over x, which is 2 minus x over x. And on this one, the common denominator is again x. And on top of that one, you have a 1. On top of that one, you have 2x. So it's 1 minus 2x over x. So you have that over that. Flip and multiply. So 2 minus x over x times x over 1 minus 2x. X's are gone. And I get that ugly looking thing. 2 minus x over 1 minus 2x. I don't think there's anything you can do with that. If I pull out a -1, that's 2x plus 1. Yeah, nothing. Coming over here, r of a, just plug in a, so it's just 2a minus 1 over a minus 2. Plug in x minus 1, so you have 2 times x minus 1 minus 1 over x minus 1 minus 2, so you get 2x minus 2 minus 1, that's 2x minus 3 over x minus 3. There's that one. 18, got an absolute value function, find g of 3, we'll just plug it in. G of 3 equals 3 minus 4 is -1, absolute value of -1 is 1. Find g of x plus 4, well, you just plug it in, so it's g of x plus 4 equals, plug it in, absolute value of x plus 4 minus 4, so it's just the absolute value of x. I don't know why I wrote that out. Another function, what is the domain? Remember, domains, all possible x values. In this case, the only thing that's going to restrict your x's is if you have square root of negative, or if you have a x on bottom of a fraction. We got a bottom of a fraction down here, so hey, and there's no numbers around it, so that's easy. X just cannot be 0. Could be anything else. Plug those numbers in. 2 squared is 4 over 2, which is 2. -2 squared is 4 over 2, which is 2. And -20 squared is 400 over 20. 400 divided by 20 is 20. Okay, this one. This one, you get the exact same thing on both. Notice they're the exact same problem. The only difference is that says A and that says x sub 0. So it's the exact same work, except on this one, everywhere you see an A, put a x sub 0, and you get the exact same answer. So I'm only going to do it once. G of x is just that, 3x minus 5, minus G of A, plug in A for x, 3a minus 5, don't forget your parentheses, all over x minus a. That one, again, same thing, just x sub 0 is there. Well, distribute the negative, and that's minus 3a plus 5. So negative 5 plus 5 is 0. So you end up with 3x minus 3a over x minus a. Factor the top, and you got 3 times x minus a over x minus a. Gone. The answer is 3 for both. Here, ooh, that's lovely. Got to plug in 2 plus h for both of those. So, I'm not talking to myself, I promise.
I learned after the first one.
2 plus h goes into there. Let's see here. I'll do it over here. So you got to plug it in for both t's. 2 plus h squared plus 2 plus h. That's just that one. Now you got to do minus. And I'll plug in 2 for both of them. So I'd do some brackets. 2 squared plus 2 all over h. So now it's just simplification. 2 plus h squared is 4 plus 4h plus h squared plus 2 plus h minus 4 plus 2 is 6 all over h. Combine like terms. Let's see, 4 plus 2 is 6, minus 6 is 0, so I don't need any of those. We got a 4h and an h, that's 5h plus h squared over h. Divide out an h, and you get 5 plus h as your answer. Same thing on here. Plug in t. Hey, it's just t squared plus t minus, plug in 2. Didn't we just plug in 2 in the last one? Yeah, so I know it's 6 all over t minus 2. So that's probably factorable. T plus 3 times t minus 2 over t minus 2. Those cancel. Your answer is t plus 3 for that one. M of x equals that. Plug in that for x. That's lovely also. Let's see. M of 1 over x equals 1 over x minus a over 1 over x plus a. Ooh. Did I do that right? Yeah. Now I just got to get a common denominator and simplify. So x will be my common denominator. I'm going to do it a little different this time. So that one already has the common denominator, so that's 1. That one needs an x, 1 minus ax over, let's see, x. It's just going to be 1 plus ax, I'm guessing. 1 times, yep, plus ax. Flip and multiply, so 1 minus ax over x times x over 1 plus ax. X is gone, so I get 1 minus ax over 1 plus ax. Nothing you can do with that. I'm back. Ooh, more of these. This is the one you guys are all getting all crazy with your calculators. I would just plug them in. So, like if I plug 2 in for f, that's 0. If I plug 2 in for g, 4 minus 2, that's 0. So that sucker's 0. F minus g of 5. Plug in 5 for that. That's 3 over 6. That's a half. Minus, plug in 5 for that. Put some parentheses there. 5 squared is 25, minus 5 is 20, minus 2 is 18. So 1 half minus 18 is negative 17 and a half. Multiply. So 102 minus 2 is 100 over 103 times, that's crazy, 102 squared minus 102 minus 2. Gonna have to go to the calculator for that one. Let's see, 102 squared minus 102 minus 2 equals that big number times 100 divided by 103. It's 10,000. That's crazy. Didn't see that coming. Oh boy, another one. So plug it in. 97 over 100. There's F divided by, plug in 99. Well, I'm just going to go straight to the calculator. 99 squared minus 99 minus 2. It's 9,700. So flip and multiply, or just go if you're good at the calculator. 97 over 100 divided by 9,700. 1e negative 4, which is move it to the left, to the left, to the left, to the left. I think it's 0.0001. 1, 2, 3, 4. Yep. That's like 10 times, or 1 times 10 to the negative 4th power, scientific notation. That's what the calculator's telling me there. Move the decimal 1, 2, 3, 4 to the left. Just add those. Well, so you got x minus 2 over x plus 1 plus that thing. So you're going to need to get a common denominator, but if you're slightly genius, you know that that is x minus 2 times x plus 1. So when you get your common denominator of x plus 1, let's see, I'm going to go down here. X plus 1 will be my common denominator. That already has it, so it's x minus 2 plus, I guess this doesn't even really help. It's not even going to work out nice. I'm trying to think if there's anything else. Yeah, that's going to suck no matter what. Plus x minus 2 times x plus 1 squared, because that one would have to get multiplied by x plus 1. And if you feel like it, go ahead and multiply all that out, but I don't, so good enough. Subtraction, same thing, just freaking put a minus. Hey, look at that, there's that one. Is that true? I gotta make sure I'm not wrong, so I don't want anyone extra credit. Hopefully I'm talking loud enough. I'm kind of mumbling, but that's what happens when you sit in a room doing math by yourself, trying to do it out loud for 30 minutes. Yeah, that's fine. Who cares? Okay, next one. Multiplication. Just multiply those. The factoring was key on this one, because you have that times x minus 2 times x plus 1. That's just over 1. Boom, the x plus 1s are gone, so it's just x minus 2 squared. And then divide them. So flip and multiply. So you have x minus 2 over x plus 1 divided by, I'm going to use the factored form again, x minus 2 times x plus 1 over 1. So when you bring that up here to flip and multiply, x minus 2 times x plus 1, those are gone, and you get 1 over x plus 1 squared. There's your answer. Let's see, these, find the inverse. Oh, easy. Minus 3, so watch, you can do these in your head. The inverse of that one, you would take, you'd switch t and whatever. So you put t over here and you put p of t in there, and then you go t, and then you would subtract 3, and then you would square root it, and then you would add 2. There's that one. This one, let's see, z negative 1 of x. You would put the x over here, and then you would subtract 3, and then the opposite of third power is the third root, and then you would add 2. So pretty much the same thing as that one. And then this one, and this one might actually take a little work. So I'll actually flip the x and the y. X equals 2 over y plus 3 minus 1. Solve for y, so I add 1. So I got x plus 1 equals 2 over y plus 3. Need to get that y off the bottom, so multiply by y plus 3 on both sides. So those are canceled. So now I got those times each other. Now divide by x plus 1, so y plus 3 equals 2 over x plus 1. And then subtract 3. So there's your answer. So what was my variable? F of x, so I'm going to go f negative 1, x equals 2 over x plus 1 minus 3. There's your inverse of that one. And then, let's see, oh, there's two more. I kind of snuck another one in there. This one, I'm going to use x and y just because it's easier. So switch them. It would be x equals y minus 2 over y plus 3. Kind of struggled with that one when I was doing it with Riley, but it's not bad. Multiply by y plus 3 on both sides, and you get that. Oops, I don't need parentheses, whatever. Then you actually have to do the distributive property here to get xy plus 3x equals y minus 2, because that allows you then to get all the y's on the same side. So now I can minus y and minus 3x, and so I have xy minus y, that's gone, equals, that's gone, negative 2 minus 3x. Factor out a y, so y times x minus 1 equals, I like to put the x first, and then divide by x minus 1, and there's your answer. So what was it was q negative 1 of p equals negative 3x minus 2 over x minus 1. And that one, well, that one's another in your header, so f minus 1 of x equals, you're going to take x, do the opposite, so you're going to subtract 4, then you're going to have to divide by 2, then opposite of square root is to square it, and then subtract 1, so there it is. Ooh, one more. Oh man, I want to do these. Okay, these are long. Let's see, I should probably just find the answers. Be a lot faster than actually sitting here and working that out. I mean, I told you how to do it. I'll just do one here. So I think on the board, you guys said to solve for, I don't remember. Solve for x, that's right, so you had to plug it in here. So it was x equals 5y minus 9 divided by 2. So 5 halves y minus 9 halves was x. So then you plug that in for these x's. So we had negative 3 times 5 halves y minus 9 halves squared plus 2 times 5 halves y minus 9 halves times y plus 4y squared. Well, then you just multiply that all out. So negative 3 times 25 force y squared minus 45 90 y plus 81 force. And then distributive property. Hey, that's nice. 5y minus 9, shoot, and then times y, so that's going to be times y squared minus right there. Look at that mumbling. And then multiply all the, by 3, why couldn't it just be a 4? That'd make it a lot easier, jeez. So it's negative 75 force y squared plus 270 force y plus 243 force plus all that crap. So my y squareds, I got 4, 9. So 9 minus 75 force. So what's that? 36 force minus 75 force is negative 39 force y squared. I'm taking big risks here by just doing this in my head. And then, let's see, negative 9y plus 270 force y. That'd be negative 36 plus 270 is 234 force y. And then I don't care about that because it doesn't really matter. Because now I'll do y equals negative b over 2 times a, which comes out to See, that's negative 78 force, but then I'm going to flip and multiply, so I'll go, oh yes, the force are going to go away, but I still have an ugly number, negative 78, so I get 234/78. Does that reduce? Times 3? 210 and 24. Holy smokes, it's 3. So y equals 3, which means x equals, let's see, 15 minus 9 is 6. 6 divided, x is 3 also. So the maximum of that thing would be when x and y are both 3. So to finally answer the question, the max would be negative 3 times 3 squared plus 2 times 3 times 3 plus 4 times 3 squared. That's 9. That's negative 27. 9 times 2 is 18. 9, 36. So that's 40. 54 minus 27 is the final answer. Not doing that one. If you really want to know the answer, because that's the one you did, you come in here in the morning, because I'm not doing it. This one, there's lots of ways to do it. I don't care. I told some people I don't care if you do A or B, as long as you can do this part on this problem. Like Riley did it a completely weird way compared to Wyatt, but they both got the same answer. So as long as you know what your x is and you know how to calculate things, then you can just do it. It's like it's called knowing math. So I'll give you just one example. I'll probably just do it the Wyatt way, because that's the first way I saw. Plus Riley's is hard to understand. So revenue. Revenue is the amount it costs per thing multiplied by the number of things you sell. So revenue, and I'm not doing A or B, equals, well, the number of things I sell is going to go here, and the price per thing is going to go here, and that'll tell me how much money not how much money I necessarily made, because that'd be profit, but it's just how much you brought in. So the number of things I sell starts at 150, but I sell 5 fewer units if I increase the price by $10. So basically, you're just like, hey, the number of things I sell, I know it's 150, but I lose 5 units every time I go up by $10, so we went like that. And for price, we went, hey, it starts at 200, but I lose $10. Oh, no. $10 hike in price. So the price has to go up by $10. So in this case, X represents the number of times you increase the price by $10. So like if X is 1, the price becomes 210, and the amount you sell would be 145. If X was 2, the price goes up to 220, and the number you sell drops to 140 following that. Now you just have to distributive property and do negative b over 2a. And if you do that, let's see, I should probably actually do it, because you have to know how to interpret the answer. You have to go 150 times 200, what is that, 30,000? 30,000 plus 1,500x minus 1000x minus 50x squared. So you get negative 50x squared. What is that? Plus 500x plus 30,000. So x equals, if you're going to maximize that, negative b over 2 times a. Did I just get it wrong? So that's 5. Well, remember, x was the number of times the price got increased by $10. So if x is 5, the price would be 200 plus 10 times 5, which is $250. So you should charge $250. And your revenue then would be 250 times, let's see if I plug in 5 here, 150 minus 25 is 125, so whatever 125 times 250 is. $31,250 is your max revenue. Expect a problem similar to this, and a problem similar to this, maybe. But if I do one of these, it won't be all fraction action. It'll be just integers. So show that these are inverses. This is how you do that. You plug that one into that, right? So you go 1 over, and then for x, you plug in that thing. So 1 over x plus 1 minus 1. And now you don't just cross crap off, you actually show each step. So in this case, down here first, I would probably, the parentheses aren't doing anything, so positive 1 and negative 1 is 0, so I'm left with 1 over x, because yes, those do just go away. Then this is division by fraction, so you leave the top, flip that, and you get x as your answer, so those must be inverses. Same thing down here. Plug that one in for those x's. Ooh, that one's crazy. So we'll go, let's see, 2, instead of x, I'm going to put that whole thing. X plus 1 over 2 times x minus 1. Plus 1 over 2, and then I put that whole thing again. X plus 1 over 2 times x minus 1. Minus 1. Now you got to simplify. So this is where you can't just cross crap out. There, Riley and Galen. You actually got to simplify it. Let's see, what are we going to do here? Well, I know that this is 2 over 1 times this, so really I've got 2 times x plus 1 over 2 times x minus 1 plus 1. And then same thing here. So 2 times x plus 1 over 2 times x minus 1 minus 1. Lots of ways you could do this problem too, by the way, so this isn't the only way. This is just what I see. Well, 2 divided by 2 I know is 1, and 2 divided by 2 I know is 1. So now I'm left with this. But I can get a common denominator here so I can combine these. So my common denominator would be x minus 1, and on top, that one already had it, so that's just x plus 1. That one needs the whole thing, so plus x minus 1. And then on bottom, I do the same thing. My common denominator is x minus 1. On top, that's already got it, x plus 1. But then I gotta go minus, and then I gotta multiply by x minus 1. So there's all that. Let's see, up here I got positive 1 and negative 1, that's 0. So I got x plus x, which is 2x, over x minus 1, divided by, let's see this, it's x minus x, which is 0, and I got 1 minus negative 1, which is 1 plus 1, which is 2 over x minus 1. Now I can flip and multiply, so 2x over x minus 1 times, flip that, x minus 1 over 2, boom, 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 there it is. So there's no way you could have just started here at the beginning and gone x. If you do that on the test, you will fail that section. Oh, and then these, dudes, you've already got all the answers for these. We've gone over this like a lot of times. The little X's were on there because I've already given them to you, so I put X's on them. But I think I've given you all of them in the entire book, so yeah. So you want the answers again? I mean, that one you could have skipped because that one's just nuts. But domain, x can't be negative 3 and x can't be 3. Range, let's see, it goes down forever. Looks like it might be all real numbers. No, this was the one where there's like nothing in here. Like that goes down, but like in this little region, there's nothing. Looks like it comes up to 1. So y could be anything less than or equal to 1. Less than or equal to 1. But also, it's bigger than 3. It never hits 3, but it's bigger than 3. So something like that, or you could write it as intervals. You could write the range is from negative infinity to 1, parenthesis bracket, because it does hit 1, union. It doesn't actually hit 3, so it would be from 3 to infinity, both parentheses. What value of x is y is 0, negative 1, 1, and 5, I think it's supposed to be negative 1, 1, 5. K is 0, so that means x is 0. What is y? Well, it's 1. K of 6, y is 1 again. When does y equal 4? Never? Oh, no, right here. When x equals negative 4. When x is 3, what is y? Nothing. As x approaches negative 3, y, or k, whatever, approaches, this is one where there's 2 answers. So you have to go, let's write it over here. As x approaches negative 3 from the right, k will approach, let's see, if I go from the right towards negative 3, I'm following the line, I'm going down to negative infinity. But as x approaches negative 3 from the left, come this way and I go up, and k will approach positive infinity. As x approaches 3, k approaches, well, this one's nice because they both go the same direction, so it's just one answer, negative infinity. This one has 2 different answers. As x approaches positive infinity, k will approach. So if you go to positive infinity, that's that way. Looks like it's going towards 0. And as x approaches negative infinity, going that way, it's going to approach 3. And at this point of 42 minutes, I am tired of talking to myself, so I am not doing that problem. If you really want the answers, come see me, but I don't even know if anyone's still watching. So, should have thrown a joke in here at the end. Let's see. If you're still watching, then let's see, how can you give me like a signal? On your test, when you write the date, you'll get extra credit for this. But you can't tell anyone else. It's got to be like secret. When you write the date, write pi plus 1. No year, just pi plus 1. If you write the year, that's, nope, just write that as the date, and that'll be like our secret code. Then you get some bonus points yet to be determined. I'm going home now.